everyone, welcome back to EnviroGeeks. I know it's been a while. I'm your host Emily, and tonight I'm joined by Rachel.
Hello.
And Jaquim.
Howdy.
And today we're going to talk about why should we care? Alright, so today we're going to talk about why should we care. So we're basically going to do a intro to environmental science / conservation biology. So the environmental and conservation field is an interdisciplinary field. This means rather than focusing on one of the sciences like biology or chemistry, we focus on a few of them. This does not mean everyone in the field is an expert in every field, but we have a general knowledge in other fields. For example, I have a bachelor's degree in environmental and conservation biology. My focus was biology, but I took classes in chemistry, geology, and geography. This is because the field we've chosen to study encompasses all of these fields. In my opinion, the goal of my field is to find solutions to and learn as much as possible about the problems our environment faces today. Does that make sense so far?
Mm-hmm.
Yeah,
Okay.
Following you so far.
What are some of the biggest issues we face?
Some of the biggest issues we face are greenhouse gas emissions, waste, loss of biodiversity, pollution like plastics, air, water, deforestation, melting ice caps and the sea level rising, ocean acidification, and food and water insecurity, which we're going to talk about all of those today.
Dang, that's a lot of issues. Why do we have so many?
We have so many because the environment encompasses the entire Earth. So, and it's all interconnected. So when one is having problems, it's like a domino effect into the others. So while these are several of the issues we face today, it's not all of them, but they're all generally connected.
That makes sense.
So the first thing we're going to talk about is greenhouse gas emissions. There are a total of 4 greenhouse gases. The first one we're going to talk about is carbon dioxide. It's emitted by burning fossil fuels like coal, natural gas, and oil, solid waste, trees, and other biological materials, and some chemical reactions. It's removed by absorption by plants as part of the carbon cycle. Though CO2 is naturally found in the atmosphere as part of the carbon cycle, humans have drastically influenced this cycle by adding more CO2 into the atmosphere, while also decreasing the ability of natural sinks like forests.
What are sinks?
So, natural sinks are the areas that remove CO2 from the atmosphere. So, forests, oceans, things like that.
Okay.
Humans have been increasing the amount of CO2 since the Industrial Revolution. While the emissions and absorption normally balances itself out in the natural world, we have thrown that balance off. CO2 stays in the atmosphere for 300 to 1,000 years. In 2019, according to the EPA, 80% of the greenhouse gases emitted by the U.S. was CO2. The majority of this comes from burning fossil fuels for energy and transportation, making up 66% of the U.S. CO2 emissions. The other 34% consisting of emissions produced by industry, residential / commercial, and other non-fossil fuel combustions. According to the EPA, in 2019, the management of forests and other lands like cropland, grassland, and others offset only 12% of the CO2 emitted.
Dang.
So, like I said, we've thrown the balance off significantly. Okay, so for the next 3 greenhouse gases, we're going to compare them back to CO2. CO2 is not necessarily the most dangerous of the 4 greenhouse gases, but it is what we produce the most of.
It sounds like the biggest, yeah.
Mm-hmm. So the next one we are going to talk about is methane. Methane is emitted during the production of fossil fuels, livestock, agricultural practices such as manure management, land use such as forest or grassland fires, wastewater treatment, and the decay of waste in landfills. Like CO2, methane occurs naturally in the environment and is emitted by natural wetlands and other sources. There are also processes in the soil and atmosphere to remove methane. However, just like CO2, humans have increased the amount of methane in the atmosphere tremendously. According to the EPA, 50 to 65% of methane emissions globally come from human activities. In 2019, according to the EPA, 10% of greenhouse gases emitted by the U.S. was methane. Agriculture is responsible for the largest amount of methane emissions, followed by energy/industry, and then waste from homes and businesses.
How can farming affect methane?
So, farming or agriculture encompasses methane produced by livestock like cattle, swine, sheep, and goats that produce methane as part of their digestive process, which is responsible for 27% of methane emissions in the U.S. It also includes manure production, storage, and land use.
Dang.
So this is why you'll hear some vegetarians and vegans talk about, they are vegan and vegetarian for the environment, and one of those things they talk about is like cows farting. And as ridiculous as it sounds, this is a good portion of where our methane comes from.
Cow farts.
Cow
Got
farts.
it.
Yep. Energy and industry is the production of fossil fuels. Methane is the primary component of natural gas and is emitted during its production, processing, storage, transmission, and distribution. It is also found in crude oil and is emitted during its production, refinement, transportation, and storage, as well as the mining of coal. Waste includes the decomposition of waste in landfills, as well as wastewater treatment.
How does wastewater treatment factor into this? What does that mean?
To be honest, I don't know a lot about wastewater treatment, but I'll definitely have to look into it more to find out where exactly it's coming from.
Okay.
If someone knows the answer, you could be the first one to write into the podcast.
There you go. Hi guys, I'm going to interrupt for a moment and insert a quick editing note. I did some more research on how exactly wastewater treatment causes the release or emission of nitrous oxide. When wastewater comes into the plant, it normally has nitrogen present, usually in the form of urea, ammonia, and proteins. This all comes from human waste, food, and certain soaps and detergents. So in order to remove that, they have to use a process of nitrification and denitrification, which is what causes the release of nitrous oxide. In addition, when the water leaves the wastewater plant, it normally still has nitrogen in it, because the process isn't excellent at getting rid of all of the contaminants. And so not only is it causing nitrous oxide to release into the atmosphere, but it also causes an excess of nitrogen in our waterways because we are not capable of removing all of it. So we are getting better in developing processes to do this more efficiently. But that is where we are at right now. So there'll be links in my description on all of my research and where I'm getting my information. Feel free to check it out. But I'm going to send you back to the original recording now. Enjoy. When compared to CO2, methane's lifetime in the atmosphere is much shorter, but it's a lot better at trapping radiation than CO2 is. Methane's impact on global warming is 25 times greater than CO2 per pound over a 100-year period. Alright, so next we're going to talk about nitrous oxide.
Oh, I know about that. That's what you put in your car to go fast, right?
Not quite. So nitrous oxide stays in the atmosphere for 114 years and has about 300 times the impact of CO2 per pound on global warming. It is emitted during agricultural practices, land use, industrial activities, treatment of wastewater, and combustion of fossil fuels and solid waste. In 2019, according to the EPA, 7% of greenhouse gases emitted by the U.S. was nitrous oxide. As with the other greenhouse gases, nitrous oxide is naturally found in the atmosphere as part of the nitrogen cycle. However, 40% of nitrous oxide emissions globally are from human activities. Agriculture, and more specifically, agricultural soil management, is by far where most of the nitrous oxide emitted in the U.S. comes from, making up 75% of our emissions in 2019. This includes the application of synthetic and natural fertilizers that are nitrogen-based, other cropping practices, manure management, and burning agricultural residues. The other 25% was emitted by fuel combustion, production of chemicals, and wastewater treatment. Between 1990 and 2019, the emission of nitrous oxide in the U.S. has remained relatively flat. Emissions from fuel combustion have actually decreased 60% since 1990 due to emission controls on vehicles.
Is that like e-check or something?
Mm-hmm.
Okay.
Yep. So we're heading in the right direction, we're just not quite there yet.
And we're definitely not going fast.
We're definitely not going fast. Alright, our last greenhouse gas is fluorinated gases. Unlike the other three greenhouse gases, fluorinated gases do not occur naturally in the atmosphere. There are four main types of fluorinated gases: hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, and nitrogen trifluoride. Fluorinated gases are the most potent and longest lasting of the four greenhouse gases. They can spend anywhere from 270 years in the atmosphere to 50,000 years, depending on which fluorinated gas it is.
Is that because there aren't any natural sinks for those?
Correct. Once emitted into the atmosphere, it distributes globally and is not removed from the atmosphere until it is destroyed by sunlight when it is in the far upper atmosphere.
Not gonna lie, that's pretty metal.
Even in small concentrations, fluorinated gases have a huge effect on global warming and are 12,200 to 22,800 times the effect on global warming than carbon does.
Slightly less metal.
Yeah.
If it has such an effect, why do we not hear as much about this one? Like, you hear about CO2 all the time, you never hear about this.
Yeah. So, like I said, CO2 is what we emit the most of, and that's why it's talked about the most. Fluorinated carbons, which we're going to go over in a little bit, have been reduced because they were found in so many products prior. We found out how bad they were for the environment, and then we've walked back on those. So they don't make headlines as much anymore. Not that any of the greenhouse gases really do, but they aren't talked about as much because CO2 is more of our prominent issue now.
Okay.
So they are emitted during industrial processes and as substitutes for ozone depleting substances. So that's the other thing, like we had that hole in our ozone, so we switched from products that were causing that issue into fluorinated gases, which then led to a whole nother set of problems.
Just because we didn't know, or because we didn't care?
That's a good question. I don't know what, where it started, if it was, ignored, or if we just didn't know how bad they were. Which I would guess that we didn't know at the time, just because till it's out there,
we don't know what it'll do.
Mm-hmm.
Yeah.
Definitely a scary thought.
Yeah. In 2019, according to the EPA, 3% of greenhouse gases emitted by the U.S. was fluorinated gases. Between 1990 and 2019, in the U.S., fluorinated gas emissions have increased 86%.
Oh, wow.
92% of the emitted fluorinated gases in the U.S. in 2019 are due to substitutions of ozone-depleting substances. Since 1990, the amount of fluorinated gases emitted because of this has increased 275%. The remainder is emitted during industrial practices and the transmission and distribution of energy. Hydrofluorocarbons are currently used as refrigerants, like AC in buildings and cars, aerosol propellants, foam blowing agents, solvents, and fire retardants. The American Innovation and Manufacturing Act of 2020 instructs the EPA to address this by reducing the production and use of hydrofluorocarbons in the U.S. by 85% over 15 years, manage the hydrofluorocarbons and their substitutions, and facilitate the transition to new technologies that aren't reliant on hydrofluorocarbons. So, we're going to talk a little bit about greenhouse gases in general now. Greenhouse gas emissions cause the global temperature to rise. Currently, there is 419 parts per million of CO2 in the atmosphere, and the global temperature has risen 1.1 degrees Celsius. So when we talk about the temperature rising, this is an average change in temperature. So some places may see a greater change, while others may have had less of a change. And while this change doesn't seem huge, the rise in temperature can have some massive impacts on the Earth. Like Australia's bushfire in 2020, US experiencing worse wildfire seasons every year, Antarctica warming up, causing permafrost to melt, the 6th mass extinction event, ice shelves melting across the world. These are just a few examples of issues caused by greenhouse gas emissions.
Those all sound absolutely horrible.
They very much are, and many of the problems we face today can be linked to greenhouse gas emissions and global warming. So next we're going to talk about food waste. 1/3 of the food intended for humans is wasted. This is around 1.3 billion tons of food. This is enough food to feed 3 billion people and is around $1 trillion US dollars wasted. While discussing the greenhouse gases, we talked about how our waste decomposing in landfills is one of the sources of greenhouse gas emissions. However, food waste emits 4.4 gigatons of greenhouse gases per year. A gigaton is equivalent to 1 billion tons. And to put that in perspective, 1 gigaton is about the weight of all land mammals in the world, excluding humans. It is also about double the weight of all humans in the world.
That's heavy.
This means that the food waste we produce emits not about 9 times the weight of all humans per year. If food waste was considered a country, it would rank number 3 of highest emitters, just behind China and the US. So in developing countries, 40% of their food waste comes from post-harvest and processing. On the other hand, 40% of the food waste in developed countries comes from retail and consumers.
So, like restaurants and stuff, or?
Restaurants, groceries, us, everyday people that are buying groceries and not using them before they go bad. And a lot of the retail comes from, especially in grocery stores, comes from the products not looking good enough to sell.
So is that why we see all these new companies popping up that are like selling ugly produce, as it were?
Yeah, that's exactly why. One of the main reasons food waste occurs in retail is for aesthetic reasons, like I said. So this is a huge issue. In the US, more than 50% of all produce is thrown away because of its appearance. This equates to about 60 million tons of produce.
50%?
50%.
People really want those sexy looking zucchinis, huh?
Yeah. This is a huge issue, not only because it emits greenhouse gases, but also because it causes food insecurity. In developing countries, food waste is caused by financial, managerial, and technical constraints in harvesting techniques and in storage and cooling facilities.
So basically places that can't store the food or move it correctly, that kind of thing.
Mm-hmm. Or they harvest it but can't gather it before it goes bad, or can't get to it to harvest it before it goes bad.
Because they just don't have the equipment or the management for it.
Mm-hmm. Not only does food waste produce greenhouse gases, but also waste resources. Food waste is responsible for wasting nearly a quarter of our water supply, which is equivalent to $172 billion US. The water wasted on uneaten food is enough for 9 billion people to use 200 liters, which is nearly 53 gallons, per person per day. Food waste also uses 19% of our fertilizers, 18% of our cropland, and 21% of our landfill volume. An area larger than China is used to grow food that is wasted.
Wow.
It's a huge chunk of land.
It is. A study in 2020 found that during the lockdown in the US and in Italy, 49% of their sample group reported a decrease in food waste. They concluded this was most likely due to avoidance of grocery stores and an increase in cooking at home.
I love to cook.
That's good. You should cook all the food in your fridge before it goes bad. Moral of the story. Alright, so next we're going to move on to loss of biodiversity. Biodiversity is the variety of life in an ecosystem and is vital to maintaining a healthy ecosystem. We are currently in the 6th extinction event, and it is accelerating. More than 500 species of land animals are on the brink of extinction and will likely be lost within 20 years. To put it in perspective, we've lost the same number over the entirety of the whole last century.
Wait, in 20 years, we've lost the same number as in the whole last century?
Mm-hmm.
That's crazy.
Mm-hmm. If not for human impact and the destruction of nature, this rate of loss would have taken thousands of years. The WWF found that between 1970 and 2016, the population sizes of mammals, fish, birds, reptiles, and amphibians have had an average of a decline of 68%.
What causes that?
It is mainly caused by land use change from natural habitats into agricultural systems. Also, as one species in an ecosystem declines, other species will also start to decline. So if you think of if you think of a food web from back in, when did we learn food webs? If you think of a basic food web, you had the top predator, and then it ate a couple animals who ate a couple insects who ate grass or flowers or whatever.
Mm.
That is a very simplified version of an actual food web. A food web is much more complex than that. And so all of the species in an ecosystem rely on each other. So while some might survive, as species start to die off, it causes other species to die off. Either their prey is dying off, or maybe their competition's predator has died off, and now their competition's population will grow, which will cause them to decline.
Kind of like how there's a lot of deer around because they don't necessarily have predators and stuff like that.
Exactly.
It's all interconnected.
Yeah, exactly. So we hunted deer's natural predators to extinction, so there was nothing to keep them in check, which in turn caused their population to grow, which then killed like all the grasslands and stuff like that because they've overeaten everything.
Mm-hmm. Okay.
Which is now why we have to control their population. Does that make sense?
That makes sense. Why don't we bring back natural predators?
We're trying. There's several programs that are trying to bring back like native wolf populations to try and restore that balance. But it's hard once a species has been depleted from the natural world. It's hard to bring it back because of the genetics and everything that goes into that.
Mm-hmm. Because you can't just uproot them and move them around the country or something like that. Or breed them in captivity and then release them, I assume.
Yeah, I mean, they're trying. But the main issue comes from when the population gets so small, they don't have the genetic diversity. So then you get a lot of inbreeding, which causes a lot of health issues. And they can't, natural selection can't really take place because there's not a variety of genetics out there.
Okay. And there's no way for us to really undo that because it's just been done.
Yeah, and we're trying. Like, there's programs where they're taking captive wolves, breeding them, and then they find wild wolves that had pups around the same time, and they switch out a couple of the pups.
Oh.
To introduce new genetics into the population.
Okay. I mean, they're accepted by the wolves?
Mm-hmm. It's going pretty well so far, last I read. So, we're trying, but there's a lot of other issues that combine with that.
Interesting.
Gotcha.
Other animals, such as pangolins, sharks, and seahorses, have severely been impacted by illegal wildlife trade. So, like, the pangolins are considered super cute, so they're often captured and traded as illegal pets.
I mean, they are super cute.
They are. Same with seahorses. They're often captured to be put in home aquariums. And sharks are often caught and their fins are cut off for shark fin soup.
Mm.
So next we're going to talk about plastic, air, and water pollution. Plastic is by far one of our biggest challenges, as plastic takes 400 years to decompose. In 1950, the world produced 2 million tons of plastic a year. In 2015, the production of plastic had grown to 419 million tons.
Oh, jeez.
According to National Geographic, 91% of all plastic that has ever been made is not recycled. So make sure you recycle. A report by Nature found that currently roughly 11 million tons of plastic makes its way to the ocean every year, and without intervention, this will grow to 29 million tons per year by 2040. This number excludes microplastics. Including microplastics, the amount of plastic in the ocean could reach 600 million tons by 2040.
And what are microplastics?
Microplastics are exactly what it sounds like. It's very, very, very tiny pieces of plastic.
What does that come from? Like, I can't think of
So-
anything off the top of my head.
Yeah, so when plastic decomposes, it breaks down into tinier pieces, essentially. So those tiny pieces are considered microplastic.
So it's part of the process of it decaying.
Mm-hmm. Which actually, there was recently, fun nature fact. Recently, they found an organism in the ocean that has evolved to start eating plastic. So nature's doing its best to
fight back
survive.
a little bit, yeah.
Air pollution is not only an environmental issue, but also a health issue. The World Health Organization reported that 4.2 to 7 million people die from air pollution worldwide every year. They also reported 9 out of 10 people are breathing air that contains high levels of pollutants.
How do we find that people die of air pollution? Like, what does that mean? People with just problems breathing? Or what does that mean?
I'm sure that's part of it. I would honestly have to ask a doctor what classifies as, dying from air pollution.
Mm-hmm.
I'm sure it also has something to do with the chemical levels that are in their body. Because if you're constantly breathing in chemicals, that's going to build up, I would assume.
An overall decline in health, probably.
Mm-hmm. Causes even more issues, but breathing issues would be the main one, I would assume. Air pollution is mostly caused by industrial sources and motor vehicles, though some emissions come from burning biomass and poor air quality from dust storms. It is currently thought that air pollution helped with the spread of COVID-19. There is a positive correlation between COVID-19 related deaths and air pollution. It is plausible that airborne particles help transport the virus molecules, although more research is needed before we can draw a conclusion on that. Water pollution is a huge issue as it can lead to water insecurity and habitat destruction. The main source of pollution for freshwater is runoff from farms. So if you remember earlier when we were talking about greenhouse gases, we talked about using nitrogen-based fertilizers. So the runoff from farms is filled with nitrogen from those fertilizers, which then ends up in our waterways. This has a drastic effect on the chemistry of the water and can cause drastic effects in the ecosystem. And oftentimes, ecologists will use frogs as their markers for how polluted the water is.
How so?
Because the frog's skin is so permeable, they take in all that pollution, and they're the first one to show signs of deformities.
Well, that can't be good.
No, it's really sad. So next we're going to talk about deforestation. Forests provide 3 main purposes: habitat, carbon sequestration, and soil erosion prevention. So by that I mean the tree's roots physically hold the soil in place, preventing erosion and mudslides.
And carbon sequestration, or however you say that, that's the sinks that you're talking about.
Yep, exactly. This is not saying that forests don't provide other main benefits, but these are the biggest 3. Every minute, forests the size of 20 football fields are cut down. If we continue this rate, by 2030, we might only have 10% of forests left in the world. Within 100 years, we will have cut down all of our forests. 95% of the lower 48 states of the United States has been tilled, logged, grazed, drained, paved, or otherwise developed.
Can we come back from that?
Mm-hmm. We can. And there's a lot of great organizations that are trying to.
Is it like those plant a tree ones or something like that?
Yeah. Yeah, where you purchase something and for every purchase they plant a tree, or you donate and they plant a tree.
And so those things actually work. That's a valid way to go about this.
Yeah. I mean, there's a lot of work we need to do, but it's a start. The leading cause of this is agriculture. The forests are cleared to raise livestock or grow crops such as sugarcane or palm oil. So, if you read an ingredient list at the store and you see palm oil in it, do not buy it. It is very bad for the environment.
We were just talking about that, weren't we? That's found in, what's it called? The hazelnut thing.
Yep, and Nutella. It's one of the main ingredients.
So even though it's tasty good, maybe don't buy it.
Yeah, exactly. And maybe find something else that is also tasty. The 3 biggest offenders are Brazil, the Democratic Republic of Congo, and Indonesia. Indonesia is taking on deforestation, and we are now seeing the lowest rate since the beginning of the century.
Is that the only offender that's trying to do anything?
That I know of. And really, if you want to make an impact, as far as deforestation goes, and just environmental issues in general, the biggest thing you can do is start with your backyard. Because a lot of our conservation issues come from the fact that we have created islands of conserved areas, right? So we have our parks, we have our national forests, we have all these areas, and it's great that we conserve those areas, but the problem is they're not connected. And so the organisms that live in those areas can't often flourish because they can't move around.
They're very secluded.
Mm-hmm. So if we consider our backyard as part of being a part of nature, then we can make an impact to where we might actually be able to bring those organisms back, species back.
So what does that look like? That means like not having grass, like a stereotypical yard, like...
Yeah, so grass is, anywhere you live, grass is not native. So the biggest thing you can do is plant native plants in your yard. Make sure you got trees in your yard, especially if you live around woods. Try and make an even bigger buffer area. Because the edge of the forest is not technically safe for the animals and insects and whatnot that live in the forest. So that edge effect can go 300 yards into the forest. So if you live near a forest, the biggest thing you can do is kind of give them an even bigger buffer zone. And again, make sure you're not using nitrogen-based fertilizers in your yard. Things like that. Which we'll talk about more in other episodes.
Can't wait.
So the next thing we're going to talk about is melting ice caps and sea level rising. The sea levels are rising an average of 3.2 millimeters per year globally. By 2100, sea level is expected to rise a total of 0.2 to 2 meters. This is caused by melting ice caps. Currently, the rising temperatures are warming Antarctica more than twice as fast as anywhere else on Earth.
Why is that? Does it look because of the location of it, or why is it such a big difference there?
I honestly have never asked that. I'm so sorry. Every question you ask me, I'm like, I don't know. But like I said at the beginning, we all study a little bit of everything. Hi guys again. I'm going to hop in here one more time for another editing note. I again did some more research on why the Arctic is warming so much faster. And it is because of something known as Arctic amplification. So what that means is that normally in the Arctic, the sea is covered with sea ice, which, when things are functioning properly and that sea ice is there, 85% of the incoming solar radiation is reflected back out into space. Now, the opposite happens with the ocean. It is the darkest natural surface on the planet, and it actually absorbs 90% of solar radiation. So, as the ocean has warmed up, it has then started to melt sea ice more. And so the absorption rates increase, which causes a positive feedback loop and causes the ocean to warm even more. When the ocean warms, that is causing more of the sea ice to melt, which means, again, the ocean is warming even faster. So this feedback loop is what Arctic amplification is, and is why the Arctic is warming at a faster pace than the rest of the world. I'm going to send you back to the original recording again, and I hope you enjoy the rest of the episode. Thanks. The greatest risk in the Arctic comes from the Greenland ice sheets. Last year, during the summer, Greenland lost 60 billion tons of ice. This was enough to raise the sea levels by 2.2 millimeters in 2 months. In 2019, Greenland lost a record amount of ice, averaging out to about 1 million tons per minute throughout the year. If the entire ice sheet melts, it will raise the sea level 6 meters. The Antarctic continent melting contributes 1 millimeter per year to the sea level rise. This is about a third of the total sea level rise. In late July of 2020, Canada's last fully intact ice shelf collapsed, losing 40% of its area over a 2-day period. This was also the last known epishelf lake in the northern hemisphere.
What is an epishelf?
So an epishelf lake is a freshwater lake dammed by ice that floats on top of salt water.
So we just lose that lake then whenever that collapses?
Mm-hmm. The sea level rise would be disastrous for those living along the coast. According to Climate Central, sea level rise in this century could cause flooding in coastal areas that are currently home to 340 to 480 million people. This would cause them to migrate inland. This mass migration would then put a strain on resources and space available. So while we're on the topic of the ocean, we're going to talk about ocean acidification. The ocean absorbs about 30% of the carbon dioxide that is emitted into the atmosphere. As the carbon dioxide increases, it drives the pH of the oceans down, becoming more acidic. The smallest change in pH causes massive effects through the marine ecosystem, species, food webs, and decreased habitat quality. Once the pH of the ocean becomes too low, the shells and skeletons of ocean organisms could even dissolve. One of the biggest issues caused by ocean acidification is coral bleaching and coral reef loss.
What is coral bleaching?
So you know when you think of coral reefs, you think of super colorful, super pretty corals.
Mm-hmm.
So coral bleaching is when they lose all of their color and they are just white. They essentially die.
And that is 100% caused by us, or are there natural factors involved, or no?
It's pretty much 100% caused by us. There's some, it's mainly caused by ocean acidification. So, animals in the ocean have a very small range of what they find acceptable. And if you're outside of that range, they cannot survive. Because if you think about it, the ocean is so big. It generally in the past does not fluctuate very often.
Mm-hmm.
So coral have a symbiotic relationship with algae. And so when they get stressed, like with ocean acidification, they release or expel those algae, which causes them to lose their color and also causes them to die, because those symbiotic algae are what is using the sunlight through photosynthesis to create their food.
Well, what happens to the algae?
They float off into the ocean, hopefully to find a new home.
Hopefully. Well, that's sad.
It is. But there's a lot going into bringing the coral reefs back and trying to reestablish them.
So can they be unbleached, or are they dead?
They cannot be unbleached. Once they're bleached, they're gone.
So can that area ever be reclaimed, or is it just it's going to be dead forever?
So that's what they're trying to do. So they're trying to essentially raise coral in the ocean on these farms that they built, which are like wood frames that they can put the fragments into. So that they're raised in that higher pH or lower pH, higher acidity. And then they can plant them into where the coral reefs used to be. Does that make sense?
Yeah, that makes sense.
Yeah.
So kind of like it will grow over it, but not necessarily grow back.
Yeah.
Okay.
So if you think, like a coral reef is essentially layers of coral. Like the Eleuthera in the Bahamas is an island that is made from coral.
Oh.
Higher acidity in the ocean doesn't allow the coral to rebuild their exoskeletons to recover from the bleaching events. Scientists have estimated that coral reefs could be wiped out by 2050. A study found that ocean acidification could be linked as an effect of plastic pollution in the ocean. The buildup of bacteria and microorganisms from plastic garbage polluting the ocean damages the marine ecosystem and contributes to coral bleaching. And coral aren't the only ones that are affected, but they're the ones that are affected the most by ocean acidification.
And I think most people know what you're talking about whenever you kind of talk about the loss of coral.
Mm-hmm. All right, so the last thing we're going to talk about is food and water insecurity. A combination of rising temperatures and unsustainable farming practices has increased the threat of food and water insecurity. More than 68 billion tons of the topsoil is eroded every year globally. This is 100 times faster than it can be replaced naturally. This eroded soil filled with biocides and fertilizers ends up in waterways, contaminating drinking water and protected areas further down the stream.
That can't be good for the fish.
It's definitely not good for the fish. It's not good for us either. So essentially we're losing our drinking water from the pollution.
Why is it eroding so much faster?
Because of the unsustainable farming practices. So the nature in general has its ways of protecting the soil from eroding. So like we talked about with trees, how they physically hold the soil in place. Because we've essentially
gotten rid of
all the trees, all the natural plants that grow here or in that area. The soil, there's nothing there to hold the soil there. And so then we farm it repeatedly, and don't have anything to keep it where it should be. It's able to just wash away with the rain.
It ends up where it shouldn't be.
Exactly.
Full of bad chemicals.
Exactly. So we've pumped our soil full of chemicals and then made it so it can just
Be carried away.
be carried away. And if you think about, like, so right now, as far as food insecurity goes, if you think about how right now we're having the price of eggs shoot up because of the bird flu, which has caused a decrease in production, essentially. That's what's happening with our food. So we have thrown away so much of it that we don't have enough to support how many people we have.
Sounds like something we could learn to manage a little bit better.
Definitely. Definitely. Because we shouldn't have an issue with that. I mean, we've talked about how much food we throw away in a year.
Right.
But that's all I have for now. Do you guys have any questions for me before we hop on off?
I don't believe so.
No more than I can think of.
Any last things you want to say to the people out there?
I didn't know there was going to be a pop quiz.
It's not a pop quiz.
Let's all make steps together.
Exactly. It doesn't take all of us being perfect. It takes all of us at least trying. Doing a little. Alrighty, guys. Well, next we'll be talking about rain gardens and how to put them into your backyard to help stop erosion and increase native plant population. Alrighty, guys. Be safe out there, and I'll see you next time.
Bye.
Bye.
Bye.